Page 10 of complex numbers and polynomials. This first one looks kind of difficult, but when you look at what they're asking, it says find the quotient remainder when this polynomial, which doesn't even look like a polynomial that we're used to, right? It's not multiplied out. When it's divided by x minus 2, and then you're like, oh, I see, it's x minus 2 times that, and we're going to divide by x minus 2. So basically, the quotient is going to be the remaining part, which is x squared plus 2x plus 3, and then the remainder is going to be 7 divided by x minus 2. So that's it. So the actual remainder here would be the 7. Let's move on to 6D, zeros, roots, and factors. Zeros, roots, and factors and x-intercepts of a graph are all kind of the same thing, but a polynomial p of x that is not an equation may have zeros. Okay, so zeros don't require an equation. It could be just an expression, a polynomial. An equation p of x equals 0 may have roots or solutions. If there is a factor x minus a of p of x, then there exists a polynomial q of x such that p of x equals x minus, I'm sorry, that's alpha, not a, times q. Okay. That's all stuff that we've seen before. Find the zeros of 2x squared minus 5x minus 12. And so this is a quadratic. How do you find the zeros of a quadratic? Well, you could factor. You could use quadratic formula. Remember, quadratic formula works all the time, no matter what. So we could just do that. Negative 5 plus or minus b squared, 25, minus 4 times a times c, negative 12, divided by 2a, 4. So that'd be 5 fourths, 25 plus 96, which would be 121. So square root of 121 is 11. So plus or minus 11 fourths. So the two possibilities are 5 plus 11, 16 fourths, which is 4, or 5 fourths minus 11 fourths, which would be negative 6 fourths, which would be negative 3 halves. So those would be the two zeros. Here's an easy one you could just get by factoring. You could factor out a common factor z, and you get z squared plus 2 equals 0. And then we know that this would give a result, a 0 of 0. Z squared plus 2, that would be z squared equals negative 2. Z equals, square root of 2i, plus or minus the square root of 2i. Okay, so those are three zeros. There's 0, there's plus square root of 2i, and there's minus square root of 2i. After example 17, find the linear factors of, and so here we have z squared minus 6z plus 16. That would be, let's see, negative b plus or minus square root of b squared minus 4a, a is 1, c, which is 16, divided by 2. So that would be equal to 3 plus or minus 4 times 16 is negative 64. Negative 64 minus 36 is about 28. So square root of 28, negative 28, so it's square root of 28i divided by 2. Okay. C. So first we're going to we have a common factor of x here. So we're going to factor out the x, and then we're left with x squared plus 2x minus 4. Then we can see that this leads to a 0 of 0. And this, we could use quadratic formula. So negative 2 plus or minus b squared minus 4ac all over 2. So that would be equal to negative 1 plus or minus negative 4 times negative 4 is positive 16 plus 4, so that'd be square root of 20 divided by 2. Square root of 20, by the way, is equal to square root of 4 times 5, which is equal to 2 times the square root of 5, so the 2 actually cancels out. You could get negative 1 plus or minus the square root of 5. For this one up here, you could also simplify that a little bit. Square root of 28 is equal to 2 times square root of 7, so that would be 3 plus or minus square root of 7i. Let's look at this last one. Ooh, this one looks kind of tricky, but notice that there's only even powers of z. So we could say, let's do a transformation here. Instead of z squared, let's change it all to t's. So let's change z to the fourth into t squared, z squared into t, and now we have a quadratic. We could just factor this maybe. T minus 1, t minus 5. Yeah, that factors. So our solutions are t equals 1 or 5. If t equals 1 or 5, that means z squared equals 1 or z squared equals 5. So our 4 possible solutions are plus or minus 1 and plus or minus square root of 5. I just noticed that they said to find the linear factors. So what we really want to do is, let's go back and do b again. So we're going to put z minus 3 plus square root of 7i as one of the linear factors. And the other linear factor with 0 minus 3 minus square root of 7i. And down here, it would be x minus 0, x minus negative 1 plus square root of 5, and then finally x minus negative 1 minus square root of 5. Okay, and then for the last one, we're going to put x plus 1, x minus 1, x minus square root of 5, and x plus square root of 5. Okay, number 5. Find all cubic polynomials with zeros. Okay, so for this one here, one of our roots is x minus 3, the other one's x minus 2, and the other one's x plus 2. And then, of course, I could have any a value multiplied times that. If I multiplied it out, it would be something like x squared minus 4 here. Last one, this one would be something like a x minus 3, x plus 1 plus I, and x minus, or x plus 1 minus I. And if I multiplied the last two factors out, I would get something like x squared plus 2x, and then I would have something like plus 2.